here is another illustration on how the summary of, the delay summary can be looked at. So here is where here is one version where you have, for example, again, waiting for materials on 1, 2, 3, 4, 5 days of the week. Okay, and here is the total time in minutes it's been quantified, and here is the actual delay, and again the total delay and the percentage delay is kind of quantified here. Waiting for construction equipment, this is the quantification. Okay, the calculation here, it's a very simple calculation, it's shown, and these can be discussion points as to why it happened, how do we ensure it doesn't happen again, what is required to remove these delays. Okay, and so this gives you more of a visual on what are the aspects of delay. So here you can say 44% is waiting for construction equipment. Okay, waiting for materials is 23%. So these are points for discussion to be able to generate and brainstorm ideas. Here is another illustration. This is for a hydrocarbon project. And you can see so this actually talks about, categorizes the delays into, you can see there's earthwork, electrical, equipment, hangars, these are the different trades, instrumentation, insulation, these are the different trades, and these are the categories of delays from rework, waiting, okay, the waiting categories and the rework categories. And each cell contains the delay due to, in electrical trade, due to rework. The delay due to equipment breakdown in the installation equipment. So, the equipment here is the project equipment, not the construction equipment. Okay, in instrumentation and waiting for equipment, what is the delay? So, this is how, so it gives you a big picture within a week as to where the delays occurred in what trades under what categories. Now, you can analyze this. You can look at, for example, rework and design and if you look at piping, in hydrocarbon, piping is a very important aspect. There was a lot of delay due to rework and design in piping. Okay, contributed to 4.82%. So definitely the design, the project manager has to look at the design aspect. Okay, beyond the control of the foreman. Or if you look at, that way you can look at the numbers, discuss it, and look at, what action needs to be taken. So, there are other numbers that will come out. Okay, we can discuss some of the other numbers. For example, here is another large number. This is looking at pipe hangers and field rework. So there seems to be a lot of rework on pipe hangers. And again, is it a tolerance issue? Is it a quality issue? Is it a drilling issue? All of these questions can be asked at the meetings and resolved. Okay, the same data is put in the form of a pie chart here with different proportions. Okay, and it's just a way of visualizing and to have more discussions on it. Now, when we compare, to kind of summarize, so we talked earlier about productivity measurement systems, we talked about work sampling, and now we are talking about Foreman delay survey. All of these are techniques for us to be able to find out, to monitor what's happening on site, to understand if there is waste, to understand if things are going as planned or not. And and in many places, so we sometimes come up with this topic as to if all these techniques are there, what should I use? Okay, and so here are some of the dimensions which we have identified to see if I'm going to compare. For example, if I use cost, which of these do you think is, what is the cost implication of productivity measurement system versus work sampling versus Foreman delay survey? Something to think about. Okay, similarly, the quality of results, which gives you better results?
Productivity measurement system.
Okay, so if you think productivity measurement system gives you good results, assuming that the inputs are correct, and we know that in productivity measurement system, for example, we have to quantify, even quantifying output can be tricky. If you remember, level of effort might have to be used in some cases. So if I don't quantify my work hours and my outputs correctly, I'm not going to get the quality that I need. In terms of numbers, in terms of formulae, yes. Okay, the error should be small, but are my measurements accurate? If my measurements are not accurate, the productivity measurement system doesn't give you good quality. My work sampling also has errors. Okay, but it probably costs a certain amount of money, which probably is less than a formal productivity measurement system. But so it's a trade-off between quality of result and the cost of implementation. So which of this do you think is the least cost to implement?
Ultimately, work sampling. Yes.
Least cost would be Foreman delay survey, because there is there's no additional resource other than the person who's already kind of helping you with productivity measurement, with productivity improvement.
But I think work sampling, I'm just doing the
work sampling is normally done by a team of people.
Okay.
So you need a team to do the work sampling.
That again gives only snapshots.
It only gives snapshots.
Whereas the FDS gives you the analyzed
exactly.
digital results.
It gives you more digital results. But then if I look at people requirement, in which of these techniques is the buy-in of people very important? In Foreman delay survey. If the foremen are not going to cooperate with me, or they are very skeptical of this and they are not giving me proper feedback on the FDS, then the FDS is not going to be worth implementing, how much ever little it costs. Okay, if I look from for example, feedback time, there are certain advantages to FDS and work sampling because the feedback comes much faster. Okay, but then balancing it with the productivity measurement system might be, if it's run well, my productivity measurement system is more accurate. Okay, another issue to look at quality of results is that with FDS, I potentially get, the cost is not only for the getting the feedback, but also for the time I'm spending in discussions, this, that, which should ideally be part of my weekly meetings and everything. But part of my FDS, I might also get solutions to my problem. And I'm also getting implementation pathways. Whereas with the productivity measurement system or work sampling, with the productivity measurement system, I'm only getting productivity. I'm not even getting waste. With work sampling, I'm getting a little more of waste, but I'm not getting any solutions. With an FDS, I'm not only getting waste, but potentially also getting solutions to tackle. So, if you look at it, if I look at it again, ease of implementation, people ease and organizational ease. If I'm starting fresh, a productivity measurement system is quite a task to implement because the process requirements are very high. There's a lot to do. We have to do this. I have to measure productivity. I have to kind of, do my analysis. A lot of things have to be in place for the productivity measurement system to yield results. Okay, but the advantage of the productivity measurement system is most lab sites already have something to do in their cost control system, or in their, the productivity measurement is already being done. The numbers are already there. I have to take my quantity measurement. I have to take my input measurement, whether it's work hours or cost. It's only a question of how do I translate that into a productivity requirement, measurement requirement. So when we talk about process, if I have to initiate a process, definitely productivity measurement is not, it's kind of a high overhead to initiate. But the fact is, most sites already have some form of it. We just have to fine tune it to get this. Okay, and when we look at technology adoption, in all cases, technology can be used to enable this process. So because in the earlier years, just the paperwork of doing this was a big barrier. Today, we need to adopt technology. Okay, and we are able to adopt it to be able to make all the computations, data, this, that, accessibility much easier. But ultimately, when we look at this question of, when we do the comparison, it's not to say, productivity measurement or work sampling or FDS. But we have to see how we can use all three, as parts of the same toolkit. Okay, parts of a toolkit, and which one do we use? So normally a productivity measurement system is already in place. How do we fine tune it to actually get better measurement? Between work sampling and Foreman delay survey, you can either choose to do both. Foremen are already there and on your work site. Little bit of training, a little bit of, enabling the Foreman delay survey kind of discussion during the meetings is not so difficult to do. Add in a little bit of work sampling on a periodic basis to see how what is the data you're getting, and try to correlate these. So what happens with, and as my work sampling non-value added decreases, why did it decrease? What is its correlation to productivity measurement? What did the foreman have to say? What delays did they identify that week? This kind of a collaborative, say, multi-point look into the project is actually required to be able to analyze and be able to monitor the project, identify the waste from multiple dimensions, and then try to remove the waste. Okay, so in summary, we have covered these techniques. I think all of them are potential techniques for waste identification, reduction, and ultimately to look at productivity and how productivity can be improved. And they have to be used synergistically to take the project forward. Okay, with that, again, there is quite a bit of supplementary material which needs to be read, and so do take up these readings to learn more on this.
In the Indian context, instead of saying foreman, we could even say frontline supervisor.
Yeah, frontline supervisor or anybody who can give information on the what is happening in the front line and quantify the delays, or is aware of what's happening at the work phase and is responsible for it.
We don't have people called directly foreman nowadays.
Yeah, we don't have to. Yeah, but we just use the term foreman delay survey because that was the original term that was used by the authors, and it's commonly referred to as FDS. Yeah.
Yes, sir. Some of the parameters what we compared with PMS, work sampling, and foreman delay survey, that is the cost parameter. So, just looking at doing the process, any PMS or work sampling or FDS, the cost part of it. Other than that, there is a hidden cost. What I'm saying is, if we don't use it, there is a hidden cost.
Right.
So, are we ready to pay that?
Right.
So, maybe the different kinds of waste in terms of that lean thinking.
Right. No. So that's a very good point. So there is a hidden cost. It's not almost all medium to large contractors will have some system in place, mostly productivity based systems. Or cost based systems, I would say. Not even, they have to do cost measurement in some way. You have to fine tune that to start measuring productivity. Now, the cost of not fine tuning it is very high, because then you're going on a trip. You're taking your project on a trip without a map, without a speedometer, without a fuel gauge, without anything. You're just, flying blind, or driving blind, so to say. So these tools and techniques are, like you said, if you don't implement, you're actually paying a much higher cost.
Exactly.
Okay, and the cost of not implementing has never been quantified. A lot of times people ask, how much does it cost? Is it, is there a ROI? But really no analysis has been done on what is the cost of not implementing.
Yes.
Okay, but this is a management decision people have to take.
Just one more question.
Yeah.
So who's supposed to use the productivity measurement system or work sampling or foreman delay survey?
Right. So the
project manager or
no.
Yeah.
The productivity measurement system is a combination. If you remember, it's an interface between the planning team and the execution.
Yes.
Okay, so it comes at that interface. I think most of these tools, the implementation of the tools is at that interface between planning and the execution team. Okay, it's in that interface. The project manager will be given summary reports, or so for example, a work sampling report. If a project manager is required to drive it and implement it, yes. But the usage of work sampling results, all of that should ideally be at that planning execution interface, more towards execution, because it's a short cycle monitoring. Okay, it's not a long cycle monitoring. But in cases where the client, the project, PMC, everybody gets involved in the short cycle monitoring, okay, which seems to be the situation in site today, yes, everybody can get involved. Okay, but organizationally speaking, this is typically at the execution and at the short cycle. It could be the project management team along with the execution. Okay?
Yeah.
Okay, thank you.